Everyone has heard of global warming, but not very many people have heard of global cooling. Environmental studies show that global warming is a current trend that in time should naturally be counterbalanced equally by global cooling. Kind of like our bodies have an immune system to fight illnesses, our Earth has a resilient ecosystem to withstand inclement conditions. Its atmosphere is a fluid environment constantly flowing towards an unattainable state of equilibrium. Earth has such large-scale forces of nature that the effect of humans abusing resources is minuscule in comparison. I'm talking about cosmic rays of solar radiation that can only be blocked by the likes of sunscreen of volcanic eruptions and air conditioning from a world of oceans. 2/3 of the surface of the Earth is covered by oceans. In this short video, notice how the majority of the Earth is covered by ocean water and clouds as a result.
Summer? The sun, beating down on tropical waters, powers the weather systems of the globe. Moisture evaporates from the warming ocean and rises to create great storms.
Oceans help cool the Earth. When water evaporates, the temperature decreases. It is called evaporative cooling. As water evaporates, the air becomes saturated. Saturated parcels inherently cluster together to form clouds. Clouds have a low thermal conductivity and high reflectivity. The white color of clouds is naturally reflective. In contrast, black is thermally conductive color. An example of this is the temperature difference between concrete and asphalt on a sunny day. Residual solar radiation that has not been reflected heats the Earth's surface and creates a reaction of water evaporation, which in turn cools the surrounding air. It's a natural air conditioner. According to esteemed Australian meteorologist William Kinnenmouth, current computer models that forecast global warming do not consider evaporative cooling, which leads to gross exaggeration of climate temperature. Not only do oceans help cool the Earth, they also help control the amount of carbon dioxide that we have in our atmosphere. Carbon dioxide is the most prominent greenhouse gas. It's more than carbon monoxide and methane. When it is hot, salt water evaporates and it releases carbon dioxide. When it is cold, salt water soaks up carbon dioxide. Swedish climate expert Dr. Fred Goldberg explains, the close relationship strongly indicates that ocean temperatures and the solubility of carbon dioxide in seawater control the amount of carbon dioxide being absorbed or released by the oceans. The natural exchange of carbon dioxide between ocean, biomass on land, and the atmosphere is very large. In only 4 to 5 years, all the carbon dioxide in the atmosphere has been recycled through the oceans and the biomass system. The annual anthropogenic human production of carbon dioxide is neutralized in nature by as little as 12 days. In other words, the ecosystem easily recycles all the carbon dioxide that humans make all year long in just a matter of days. So if humans aren't a factor when it comes to the most prominent greenhouse gas, what about volcanoes? It is true, when volcanoes erupt, they do emit carbon dioxide, but mostly they release sulfur dioxide. When a major eruption occurs, sulfur dioxide is blasted all the way to the stratosphere, miles above the Earth. Then the ecosystem oxidizes it and turns the sulfur dioxide into sulfuric acid aerosols, which is a natural screening system. Major eruptions increase the volume of our atmosphere and create a filter for pollution as well as solar radiation. American geophysicist Peter Ward says sulfur dioxide is the most voluminous chemically active gas emitted by volcanoes, and it is readily oxidized into sulfuric acid normally within weeks. This effect is a significant influence on climate. All major historic eruptions have formed sulfuric acid aerosols in the lower stratosphere that cool the Earth's temperature a half a degree of Celsius, typically for 3 years. Apparently, volcanic eruptions actually contribute to global cooling, and they don't have much effect on greenhouse effect. Again, carbon dioxide is the most prominent greenhouse gas that is regulated by oceans and the biomass system. We've proven that human and volcano effect on carbon dioxide is negligible. In fact, carbon dioxide is just a rare trace gas. It's only a small part of the atmosphere, found in concentrations as low as 0.03% per volume. That's 0.03%. That means that other greenhouse gases like carbon monoxide and methane are even more rare with less of a trace. German physicist Dr. Gerhard Gerlich and Dr. Ralph Teschner report that according to the second law of thermodynamics, a planetary machine, such as the greenhouse effect, can never exist. There are no common physical laws between the warming phenomenon in glass houses and the fictitious atmospheric greenhouse effect. Earth's atmosphere is resilient. It heals itself throughout the ages. It is a fluid atmosphere with waves of crests and troughs. It's an ecological compensator with complementary opposites like yin and yang. As the sun is to the moon, El Niño is to La Niña, and global warming is to global cooling.